Okay. How many guys? Let me give me a minute. You're live on. Okay. So let me set it up quickly on YouTube. On yeah, I think we're live now. GM. Let me make a. That's the button I'm looking for. We're live for day 3 of Quasar. Aha. Okay, let me make that post and let me check the status of it. So setting everything up. Let me make a few tweets. I make a tweet and I'll share. Okay. Not. This one does. Three, of course. One more minute. Yeah. Let me share. Okay, we should do. Aye, so looks like we can get started now. Yeah. Okay. Yeah, okay. So let's pick it up where we just pick things up where we stopped last week. That was Saturday. Yeah. So what we're working on then was okay. Let me see. Let me see. Let me see. Let me see. Where's that long? Yeah. Let me check to make sure. No, this one. No, no, no. Yeah. A minute. Yeah, guys. Sorry, we starting late. We had uh some technical error issues in the morning, so I had to shift it to you now. And now I'm still setting up. Sorry, guys. Chat. I see. Okay. So what we were able to cover last week, we were able to cover installing Quasar. What's and we got familiar with Quasar, everything around creating an account, what the instruction looks like, what the structure of a Quasar program actually is. So we're still going to build on top of that and touch. There's a maybe we build a just do some complex things around, not complex per se, but some advanced, little advanced things with data structure and all inside your programs if you need to do that. So we'll talk about that. Then we'll look at the flame graph profiling and performance, CU profiler. Yeah, so we would do that. All of this. Yeah, this is a very good feature from Quasar. You can just check it out before we get to it. But let's get started. Let me pull up the repo we're working with previously. Um, we go to documents, Solana, and for some reason it's still called Hello World. Yeah. Okay. So let me bump the font up a bit. I do not do that to yourself right now. Take your time, Rust Analyzer. Take your time. So we're building a simple escrow program, and like I said, the new way to write Quasar, the unreleased new way is new but unreleased. Yeah, but you can install Quasar from the GitHub repo directly. There's no release version yet. So now, like we talked about last week, we got rid of lifetimes. No more lifetimes on this place. Uh, yeah, so no more lifetimes in your instruction account. Then we said you could invoke an instruction directly on a program ID. So you can do a CPI directly on the program account, on the program ID of the account. So you pass this program and you just do a CPI, invoke the CPI on top of it. So if it's a token transfer also, we will do self.token program.transfer. So let's try that yet. So we will do a, this one is for deposits. Deposits. So yeah, so we'll do a deposits SPL token. What else should we do? Okay, before then, let's get into the test and the state. Just to recap, we said every every struct, which will eventually be data into an account, needs to have a discriminator set here, because this is not anchor. This does not do all those CU intensive stuff under the hood. So it needs you to be explicit. It doesn't want to use those 5 bytes, 8 byte discriminator here. So you have to use specify a discriminator right here. And yeah, so that's that one for the account here. And for the test, we later got, okay, let me take it step by step. First thing, you have your setup. You have your setup. Then you load your data, your program data, your program ELF file, and you inject that into your Quasar SVM, like your Solana virtual machine. Let me bump the font up a bit, still too small to see. So you inject that into your Quasar SVM here. All these things are helper functions, yeah, helper functions, and another helper function. Is basically us building the instruction from scratch. So you have this instruction struct here, and you have, like, every instruction needs to comprise, it needs to have these three things: your program ID, the account that this instruction needs to run, and the data that are passing to said instruction. So the program ID is the entry point. Where What program are you talking to? So the accounts that are needed and the data here. But if you were to use the helper from clients, you would have something like this. So you don't need to build it yourself anymore, just like how Anchor does it here. But this one is more structured since it's roster. So you have this deposit instruction struct. Then you just pass in the account, system program, the vault, and vault state. Then all the other data, the data that your instruction needs. But I don't want to use the I don't want to use the instruction helper. I want to chill glass, build an instruction, build it from scratch. So yeah. So we built this instruction for deposit here. It just takes in the payer and vault state, vaults and program system program, then returns an instruction which has account meta, it returns an instruction basically. And this is the data that we're passing to it. This one is the what's it called? The discriminator for the instruction. This instruction is deposit, yes. If you come to deposit, if you come to Libares, you see discriminator 0 is for initialize, discriminator 1 is for deposit here. So that's why we have one there. And I'll make that look nice now. So I said it last week. It could be nicer. Yeah. Let me see. Okay. Sorry guys. I said it last week. Yeah, we could make that cleaner instead of just passing in this like this. So let's start from that. Let's IX data. Let me call it IX data is let's mute IX data is uh just do an array of, so I want to know, let me fill it up with zeros first, since it's just 0 U8, I'll fill it up with zeros. From the data is one length, the discriminator is 1 byte here. So 1 byte plus what's the length of this amount? This is a U64, yeah. So that's 8. So that's just it. So just 8 plus 1. Just put 9 there. I'm smiling at myself because I'm making this confusing. The aim is to make it simple and it's looking confusing. But okay, what I'm trying to do is I'm just creating a a container that will hold all the data, and I need to know the length of it. But I could just use a vector though. But I want to use, let me use a vec. Let's say vec with capacity. I want to create a vector with maximum size of 9. I think that everybody can relate with that one. Yeah. Let's use a vec then. but I'll still come back to that byte. So yeah, we create a vector with capacity 9. Then we say the first um ix data dot push um as it push the discriminator of the instruction is 1, yeah. Now let's put in the rest of the data. So we can do ix data, then from 0 from 1 to uh ix data dot len. So you have copy from slice this 1000. I mean, was it this 100? Yeah, come from slice 100. So I can remove this. Hopefully, no errors. Yeah, no errors. And inside data, I can just pass in ix data. Yes, and this is an error. So it cannot borrow as immutable because it's borrow as mutable. Yeah. Just reference to that. Let me just write 9. I know the maximum size here, so let's just write 9. Let's write 9, bro. Okay. I don't want to start casting it to U8 again. Just write 9 there. So I created a vector with capacity 9 because I know that the instruction data has 9 bytes. The first byte is the discriminator, then the remaining 8 bytes are a U8, a U64, which is just 8 bytes. If you don't write 9 here, you can write 1 plus U6 because it's U64, yeah. U64, then what is it? Uh Max, the learn that's right, the 12 bytes. Yeah, okay, I'm just messing around there. I started messing around again. Let's see. Let's see. No, I'm not doing that. No. There's no time to mess around. Now let us leave it at 9 because we know that it's 9. Yeah. Let's test it if this nonsense that I did actually works. uh, this is one way to clean it up. Is one way to clean it up. Well, let's see if the deposit actually runs like I most likely going to fail though. Yeah, it failed. So let's see. Why did you fail? Index 9 out of range for slice of length 1. With slice of length 1, there's one nonsense I did there. On the deposit instruction, yeah, right here. I did from index 1 to what's the maximum length of this thing? Oh, it's a vec. Yeah. So it said I should not use, cannot borrow mutably. What I did not borrow mutably? IX data len. Consider removing the borrow. I'm not removing the borrow, bro. I'm not removing the borrow. Okay, I know what I'll do. Let me just remove this vec with capacity. Since you already know what's going on there, yeah. Let's assume let's assume we have 9 here. Yeah. Expected integer found U8 size as U8. Uh, okay, so it should be a U64 there. Should be a U64. What's wrong with me today? U64. I'm just messing around, guys. This thing should work. So I cannot do the push on it. Yeah, that's obvious. 0 equals 1. 1 to 9. Just give me 1 to 9, bro. So now let's test it again. Which we still like if whatever I say. It expects, yeah. I should do dot to vector. Expect the vector I'm passing in byte slice. I'm sure that 9 will still fill. I think it should be. Let's test. Let's just test it. It's no, I'm in testing. Yeah. Yes. And now we have a test passing. What the problem was? Let's see. I think it's this vec. So this vec with maximum capacity where I got. So it's this. Okay, I removed it already. That vec with maximum capacity 9. Maximum capacity 9. Should it be maximum capacity 10? Oh yeah, you get the gist, yeah. So instead of doing this one, this is basically the same thing, but it's not expressive. You will not understand what's going on there. I have a 1, that's for the discriminator, and I'm telling it it's a byte slice, and I have 100 lamp pots here as bytes also, and I'm saying it's also as a byte slice. So all those type casting, that's what I was trying to avoid. It's ugly. This one looks better, but it's still ugly because I'm still having to do the 2 early bytes on it. Yeah. Everybody gets that. So let's get back to what we're talking about here. Um, 1 minute, 1 minute. We're trying to flaunt our byte array size. Yeah. Okay. So I wanted to say to try out another instruction that just does depositing tokens instead of depositing SPL tokens instead of and everybody okay. Wait 1 minute. We did not implement withdraw. We don't implement withdraw. Please note that the what I'm writing here is not I don't say it's not secure because I'm not doing a lot of checks, but this one is secure enough. I'm validating that this account is this, and I'm not using this voice state anywhere. I just pass the account. I'm not checking that the authority is this, the address is this, bump is this. So don't assume this is secure, right? These guys were just trying things out. Disclaimer: this is not financial advice. uh, so let's do another function that is called withdraw on a deposit struct that is counterintuitive. But yeah, who cares? So this time we are withdrawing from what's going on again? From the vault, which is a PDA. I ran from the vault, which is the PDA, to the payer. Let's see. Far it should be the invoke signed. Yep, invoke signed. So you're transferring from this becomes the from, this becomes the to, this is the lamp port, and invoke signed is taking in it expects a what is it expecting? An array of seeds. This method takes one argument, but 0 is supplied on argument of seed. We can do. I'm trying to see if we can be clever here. Instead of rewriting it, let me see. Initialize. We have this one for the vault. So vault PDA seeds. Let me see. Wait, is it expecting an array of signer here? No, it's expecting an array of seeds. An array of seeds, not an array of signers. Yeah. Let's see. What's the best way to do it? Seeds. Seeds equals seed. Seed. No, I'm sure that's nonsense. But let's see. Seed will have a You know what? I'm just going to come to the repo. Yeah, yeah. That's more interesting. GitHub. What's the word again? Blue shift. It's probably be seed, then angle bracket, something, something. But yeah, let's just check the examples. Check examples. And inside examples to be escrow. No, let's see. Yeah, escrow is nice. No, let's do the vault one. Let's see the vault one and let's do the source. Let's do the instructions. Let's do the withdraw. And inside the withdraw, lamp. No, 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 don't do this to me. It's doing the lampot that text. It's directly manipulating the lampot. No, we don't want to do that. Um, and an unchecked account. Is this a system account? The system account. Let's see. Let's see. Let's see. Okay, 1 minute. Let me check the escrow one. I should have just gone with the escrow one. Instructions. It should be in the take or maybe refund. Let's check refund first. Withdraw tokens and close. Seed from. Yep. Muhahaha. Alright, let's see this. Yeah. 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 Okay, cool. That should work. We've stolen that. So that should work. Yeah. Bumps is self dot vault state dot vault bump. Wait, do I have a vault bump? Hold on, hold up. State vault state. I have a vault state. You don't have a vault bump. Vault bump. UH. Yeah. So in the initialize, we put in bumps dot vault state. Then vault bump is vault self dot vault bumps dot vault. Yeah. Bumps dot vault. Yep, that should fix it. Hopefully, and we are happy now. And in the deposit, we can get our bumps from self dot vault state dot vault bump. Yep, vault bump. Why do I have a function called vault bump? Should just be a U8, a simple U8, bro. Okay, and for the seeds, we have a scored vault. Yeah, I just got good news, guys. Yeah. Um, 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 Back in classes. Yeah. Before then, let me see what I'm working on. The vault seeds are vault and the user address, the payer here. So self dot payer dot address dot sref, then the bump. Yeah, yeah, yeah. Seeds. It should be a borrow though. I know. So we have seeds, is an array of seeds. We should just borrow that. And we're good to go. Hopefully. Let's check our libres. And call this let's call this withdraw. Should be withdraw so. Withdraw so still taking a deposit context. Guys, don't try this at home. Should be a withdraw. But yeah. And if you have CTX accounts that withdraw, okay, it's not saved yet. So we save that. And we have the discriminator should be 2 now. We're gonna have same discriminator on different instructions. It is alive. Yeah, I think. So let's build. We build and we see. Quasar build. What do I have to build in? Whatever. Okay. While that is going on, okay, that's done already. So let's do a withdraw instruction. Let's call this withdraw instruction. We need to have a withdraw instruction, which is the same thing as the deposit instruction. Yeah. For now, different discriminator. Withdraw so instruction. Okay. So we have a withdraw sole instruction, and the discriminator for the withdraw is 2. And we're withdrawing the same amount we deposited. So yeah, same accounts, same everything. Just want to test it out and break things. Yeah. Let's go. You guys can tell I'm chill today. But yeah. This would be a function withdraw. So this is very ugly, by the way. There are better ways to write this function, this test cleaner. But yeah, nobody asked me. So let's pretend this is the only way we know. Withdraw sol, and I I'm sure I spelled something wrong here because the autocorrect was withdraw sol instruction. So where did this there withdraw? Under WITHDRDD. So how was it autocorrecting me? Withdraw sol instruction. Discriminator here is 2012. Yeah. And so let's just do a withdraw. So this will be called withdraw instruction. And this is withdraw instruction, withdraw sole instruction. And we have a withdraw result. Withdraw sole results. Copy this. Place this here. Yep. 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 Why am I having the what the fuck? Yep. Yep. Errors. Yes, one error, yeah. This should be a withdraw. So withdraw so what's it called? Withdraw instruction. And we should be good to go. So Quasar built. Did we build the last time? I think we built the last time. And this should be withdraw. And we should have a beautiful error. So we have to do all 3 instructions again, yeah. So we initialize. This will fail. Supposed to initialize, then we deposit, then we withdraw. So let's do the deposit one. Yeah, now set success. You can make this into helper functions. So you basically don't have to write this every single time, which is what I should do. But I'm not doing it. Yeah. So are we good? Are we good? Vault after state creation. Vault state after. User value moved here. So let me do where did I create this first? So let me you moved it. So we have to unmove it. Muhaha. Yeah. So this one is deposit results. Then we have a deposit results. This will just shadow the previous one, yeah. So this would work, hopefully. We could also results. Okay, so let's make this test fail. Let's go, baby. Let's go. Run the withdraw. So and fail. Oh, we passed. Yay. So now we have yeah, I know what you know why this is 11 110 instead of 100, because where we are doing this, we are automatically funding the user again in the what's it, yeah, with the signer here, we are always funding the user one 1,000 tokens every time. So that's why we have 1,100 tokens at the end. Yeah, 1, 2, 3, 4, 5, 6, 7, 8, 9. So that's why we have 1,100 tokens at the end instead of 1,000. Let me see. So instead of create key system account, it does what? Create a system owned account. That's the only thing this is doing. But we know that it works, right? So that's all that matters. So yeah. At least you can see the state changed. Yeah. So let's investigate that the state actually changed. We had payer balance is now 1 1. So let me log out the payer balance after it deposited. So let's do that. What we're doing here previously on the initialize on the deposit. Let's log out um uh payer balance and this one. Yeah, let's do this. So immediately we finish a deposit instruction, we should log out deposit, and we have an error. No error. Yay, no error. Payer balance. Let's call it after deposit. Then vault balance after deposit. Yep, yep, yep. And here comes the rainbow. Withdraw. So that means assumptions were correct there. Since it's a PDA, we should use the seeds. Okay, don't mess with me. Yeah. He didn't mess with me. So we had 9,000 after we deposited. That means the balance reduced. And we had 1,000 inside the vault. And now the vault balance is 0 and the payout balance is 1,000. It should be 1,000, but because you know why? Because we're always writing to the accounts every time that we want you to be 1,000 every single time. But we could just remove that. We even should. So yeah, let's do this. We create an address every single time. So we want to return an account here. So on this signer, it's still the same thing. I'm not going to lie. What's on my head? It's still the same thing. It's going to do the same thing. I was saying, instead of always dropping this guy, we can just create an account for him. Yeah, I don't want to do that. Let's do that. We'll have to fetch the balance. Yeah, I don't want to do that. Okay. What we should do though is f- signer 7 places. Okay, not that bad. Not bad. So instead of signer, we would say, okay, yeah, could this is in the initialize, we could use that there. But in every other place, we will be using, instead of using a signer here that writes to the data every single time, we can just do an account. No. We can just fetch the user. Yeah, we can fetch, but payer is a new public key. Yeah, Oh yeah, yeah, yeah. I know why now. I'm doing initialize here. Yes, we can do a signer here, but for the deposit, yeah, we should not put a signer anymore. We should fetch the guy. So let's have a signer. Let's signer after creation. Yeah, that should do it. Let's signer after creation will be a result dot accounts, and that will be the payer address. Payer. We've not even gotten to what I wanted to do today, guys. But yeah, it's cool. Dot unwrap. Dot clone. Yeah. So that's sign after creation, and here we'll pass a sign after creation. That's all. Sign after creation for the deposit, and here we also say user after. Yeah. So on the withdraw, we can do the same thing and call the guy sign after creation because we don't want to be airdropping tokens to the guy every single time. So after for the deposits, we are going to do a sign after creation. I will put a sign after creation here also. Error. Where's the error? No errors. Okay, sweet. One more time for the yeah. But now since it has moved, we would need to call it yeah. Signer after creation it has moved. Should have an error. Yeah. Yeah, it moved already. So let's fetch it again. So let's call it let's signer after creation. Yeah, we shadow it, bro. Signer after creation. Yeah, no. I already did that now. So I'm just paste that in. And we are good to go. So now we should not have that 1100. Now it should be 1000 exactly. Hopefully, if my math is correct. It's wrong. But there's only one way to find out. Tests. Yay. And we have something else. Okay, yeah. It's actually cool because we're paying gas here. So okay, so that's cool. So initially we started off with 1000. We deposited, we paid gas, and after the we don't have a 9000 anymore. Now I have a 89999. Yeah. So yeah, that should work. So let's get to trying out token deposits. Token deposit and withdraw. Is that time? There's still time. Still got time. We got time. So let's write an instruction that says deposit token. So if you're just joining in, yeah, you can also have a feel of what it looks like to write from scratch. Yeah. So let's call it deposit spl.rs, and we are going to do. Let me pull it in the mod rs mod deposit spl pub use deposit spl and everything inside of it. Okay, cool. So inside this place we can just do use Quasar lang prelude and every single thing inside of it. Then we have an account. Drive an account. Not this one. Derive. I said derive, bro. Derive accounts. We have a pub struct similar to Anchor, yeah. Struct. I will call this payments because it's doing both payments. That's how payment struct, and we have an implementation of the payment struct. Payment, yeah, implement payments. Okay, so yeah, we pretty much have all the same accounts. We need someone to sign for the transaction, and we obviously need all these accounts here. So let me copy all of them. System program, we need system program to create the accounts. Yeah, and we need some other accounts. So remove this one. On it, no use for it again. So now we need vault states, bro. Vault states. Vault states. Vault states. So vault PDA. Okay. Do no longer need this vault. We need a SPL vault. So the SPL vault will be, so let me put in a token program. Token program. Token program, that will be program, then token. Uh, Confirm 1 minute. Token program. Yeah, it's correct. Probably. Then import that for me, bro. Oh yeah. Why is it not? Do I? Okay, okay. I need to have it from token right here. So import it from Quasar SPL Prelude. This is still failing for me though. But let me see. Let's try. This is failing. This particular package is failing for me. Yeah. Quasar SPL tells me does not know how to resolve Quasar SPL because it's not imported or resolved crits. I don't need you, bro. Let's get out here. So Vault PDA. I do need you. No, I do not need you. I think this one. So Vault PDA. I do not need you. So it will not be So Vault PDA. It should be a token account. Let's see. What do we have? Token. Say token account. Not token account. Program. Token program. It has to be token program. But let me see how it was imported here. Because it keeps failing if I just import it directly. Let's see. Cargo terminal. Inside of it, I have, of course, this is to still break. Let me see. SPL token interface. No, don't need that one. So I come here, my cargo terminal, try to paste it, and I start showing glass immediately. But this breaks for me, is what I'm saying. Let me see. Let me see. Let me see. I immediately start to have a, that's what, yeah, I was even saying it. Quasar SPL failed to resolve use of link. Quasar SPL, bro. I just linked it. I'm saying cargo tumble. What's cargo tumble? So what's the problem here, bro? And I should have like 700 errors now. Let's see. Let's let it run. Let it cook. Why is it building for 9 days? Still building. Okay. Yeah. Token program. So what's the error on deposit? Why is there an error on deposit? Seed. That is what I'm saying. That is what. Why is Blue Shift messing with my head? Is do I need to specify that I do not want to import? I don't want to import everything from. Uh, the problem is most of the things that are exported from Quasar Lang is also exporting them in Quasar SPL. So it's seeing this looking at two different versions is what the problem is. Ah, now it's telling me I have what's the problem again? I have two different versions of seed. A thread with a similar name exists. Fail to resolve. No, that's not even what the problem is yet. Quasar Lang CPI seed. Let's see if this one fixes it. Oh, that fixed it. I was rage baiting for nothing. Well, that's build. That's where the errors mostly come up. Quasar build. I should have like 70 errors, give or take, or just none. Build, bro. Build, build, build. Damn. Actually built. So I was rage baiting for nothing. Okay. Okay. Let's get the party started, guys. Okay, deposit SPL. Okay. 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 I nail or not you, bro. So it needs to be on SPL vault to be a token account. Yeah. So I have token and it will be this needs to be idempotent because we have not created this vault before. So if we haven't created it, it should create it just like init if needed. But we're not going to that yet. Okay. Token authority is should be a token account, bro. It's be it an account token account or a token account. Yeah. Source deposit instruction say make. So why not? An account and a token. I gotcha. Why do we have a token account if we have an account token? Token means yeah, okay, okay, okay. I think this is a new way to do it here. Okay, okay. Let's paste that in here. But I did see a token account. Let me see. Token account. That's a token account, bro. What's the difference between a token account and a token and a token? Let's see. Token account is an account. I okay, no, 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 no. It's not it. That's it. Token account. It's an account. How about if I just did token? It's an account view. just an account view with token data. What's token data? Token data is still same, so it's basically the same thing but with different. I'll just use token account. Yeah, yeah. Token account does it for me. So we have token. Okay, I'll put token inside its own token macro here. So before then, I need to init this account only if it's not already initialized. So init if needed. That's basically what that's saying. And we specify the payer who's paying for this, then the mint authority. So this, oh no, sorry, payer, no, it's come after this. This put a comma here, the comma there. So now we need to specify the mint. So for that, we need a mint account. So let's copy this. Mint is going to be an account. That should be easy, and we should have a mint. Yay! Yay! If I'm using Quasar token mint, if I was using because I'm using token accounts, I should use mint from that same place. Yeah. So that's an account. That's an account. And I'll have an error. Threads account load is not satisfied. Let me remove that. Let's save now. I said account load is not satisfied. Okay, yeah. Let's see what we can do with the mint later. I think we should do something with the mint here. Bro, they're not doing anything with the mint. It's just a mint account. It's probably using mint from a different place. Uh, oh, mint authority, mint authority. All right, let's just get started with this one. I'll come back to that. Payer is payer, not say maker. So for the token constraints, we say the mint of this token is equal to mint. Let's say the authority say say of this token account is vault state. Vault state. Yep. One more error. And I think I need to put the I think I'll just go with token here, guys. Sorry. Sorry for having your hopes up. I'll just go with this. I can't start fighting this error right now. So let's use what we have from the examples. So we do the authority, we do the mint, then we specify the program ID, token program. Yeah, are the three important checks. Save, and we should be good to go here for the SPL vault. So create it if it doesn't exist. What's next? I think that's all. So now we do the deposit SPL pub function deposit SPL. It's going to take in a mutable reference itself, and that's all. An amount, obviously. Gonna be a U64. Come on, boys. Let's go. And we have Now we do ultimately we're gonna do a self dot token program dot address. Of course not. That's not approved. We want to do a transfer. Transfer checked is what we want to do. Yeah. So like every single instruction that you could do on a token is listed here. You could approve a token, you could burn, you could close the token account, you could initialize an account three, you could initialize a mint two, you could mint to someone else, you could revoke, you could transfer check. Yeah. So those are most of the instead of using the account struct. Good news, good news. Just get it. I thought backwards for ADV starting. I don't know when it's starting, but I got a mail about it now. That's what I'm looking at. Transfer checked. So let's transfer from who. So the from is taken in account view. Is it mutable? Is moving it here? Moving. No reference to it. Let's do a from is. We also need the user's token account. User's token account. Let's just do this one. Is token account. Let's call it user token account. Yeah, so this one is mutable. We don't expect you to create a token account for you. If you don't have a token account, how are you making the transfer if you don't have a token account? Yeah, and the authority here must be the payer. Uh, I token program must be this, and we have that, and I think we're good to go. So from here will be self.user token account. Yes, borrow. Then two, the mint will be self the mint. Yes, that's to account info, account view. Sorry, that's to account view also on this one. I think those two should be clear. And we have more. Who am I sending to? I'm sending to self dot SPL vault. That's to account view. Account view. The authority here is authority of the transfer. That is me. Self dot payer dot to account info, account view. Amount is amount, and decimal we can get decimal from self dot mint dot decimal. I think. Yeah. Yeah, everybody's happy now. Yeah. Not quite. Dot invoke invoke. Is there an invoke raw? 1 minute. Let me see. Yeah. So what's the problem here? Saying expected six arguments found four. Expected six arguments found four. One, two, three, four, five, six. One, two, three, four, five, six. I missed the comma somewhere, most likely. One, two, three, four, five. Oh, oh. Wait, was I supposed to do this? I was supposed to do this, yeah? Yeah, I was writing a struct inside the function call. Fucks me. And now we have another error. Smart type found CPI call. Yeah. Now we can have it dot invoke here. Dot invoke. Yay. Everybody's happy now. Please tell me you're happy. And now you're saying as account view is not satisfied. As account view is not implemented for account view. How is account view not implemented for account view? Ah, that's token account. Let me see. So he's just not using it as an ATA, as an account view, just passing it as an account. Self.user token account. Let's see, that works. Oh, so you don't want it as an account view, but you said as account view. Okay, as account view, not account view. Mm. And we should be happy now, yeah? Are we happy? I think we are almost happy. The use the method for result option. You cannot use any method that returns happy now. No, we're still happy. Happy now. I just did okay, let's see. That's okay. Uh, yeah. This did not even need. Okay. I think I know what the problem is now. Should have said you return a result. No, I don't want you to return any result. Just to like, just we are cool, bro. Everybody's cool. Is returning a result or program error. You can return a result or program error too. Let's return a result or program error. The result. Don't you know what the result is, bro? Result or program error, and now we should have an error here. Need this. Don't need this. Don't need the okay anymore. We just need this, and that should be cool. Yeah. Deposit SPL, and I think we can now bring that into the librs. Call a new instruction called deposits here. So let's copy this, paste that, paste that. Paste this one over here as discriminator 3. Then to be in the payment struct. Payment. Then we do an amount to do just deposit SPL. Yeah. So what's the problem? Let me define multiple times. Deposits. Okay, deposit SPL. My bad. And everybody's happy now, yeah? Okay. Now let's get to our rough tests. This test is very rough. I think I will uh mm, let me put this inside a tests folder. Yeah. So the tests folder. And we'll put this inside the tests. I will call this mod.rs, and we'll call this deposit test.rs. Yeah. So inside mod, we'll call test deposit. No, withdraw, just deposit. Then inside deposit test.rs, paste this in, and include it inside our mod.rs. Just mod. Deposit tests. Yes, that's good. Then we now face the errors inside deposit tests, because we need to know what type errors. Give me errors. Yeah. Setup should come from test setup. Pub key should come from pub key. Then errors initialize instruction can come from the mod. I Cyanide helper function can come from the mod. Empty can come from there. Also, oh no, test empty. I think this is the wrong cyanide input. Okay, cool. And more errors. The errors deposit instruction can also come from there. An address can come from there as well. Uh, so more errors are there. Address, especially the type found a trait. Yeah. Not lang address. So yes, type nonsense. and it should be working now. I think my mic's working now. Yeah. Okay, the mic is back. Sorry about that, guys. Thanks for letting me know, Jen. Where were we? We're getting an assisted token account. So it's made up of the wallet address, token program ID, and the token mint. So in what order? I think Ilios had a thread for that, a thread, an article. So we have to manually derive it. I'm sure there's an easier off. Just check. Just check. Take the example. But there is a better way to do. Uh, Let me check the example. I don't want to start deriving it from scratch anymore. Let's see. Oh, it did. It meant then make RTA. It just it just created the mint from thin air, bro. So let's see. Ilias PDA. Ilias Ilias had a good article on that. Can just copy it from there. Yeah, should be this one. From so updated for 2026. Yeah, cool, cool, cool. Made up of made up of no, definitely not this one. Uh Search engine is not optimized. Let me see. Resources, no resources, text. Mm, okay, I think it's in this order. Should be in this exact order. That standardized locatable address forwarding token balance itself forward balance. So it should be the wallet address, that's the owner, the token program ID, and the token mint address. So let's hope that's it. Let's try that. Seeds are the address is the payer.address. Payer is an address already, yeah. Dot address. This dot two bytes. It's me. Then we have the token program ID. Token program ID. Then we have the what else? The mint. And I've not created a mint yet. So let's do that. That token mint equals create a mint. Create a mint. What the address is? Just give me, bro. What's the create a mint address? This one. Okay. I see what he was doing. He was just pouring the account into it. Yeah. For token account, it did token account. I already have the upper function. Why am I even creating it from scratch anymore? I am being delusional right now. But let's see. I so let me just use this instead. Create a mint, then token account would come from whatever the account is. Let's say Let's token address be a pub key new unique. I think yeah, pub key new unique instead of creating it from scratch. But I could, yeah. Let let mint is pub key new unique also. I'm already regretting this I'm doing. But address is at this mint. Okay, this is the address of the owner of the token. What the 1 minute, guys. Create a mint is asking for address of the mint and the authority of the mint. The address of the mint would be mint address. Let's call it mint address. Mint address. Then the authority would be payer, since payer is a good guy. Let's make him the authority here. And we'll have so what else? Expected address found. Do you want to move this? Why do you want to move it? Yeah, sorry guys. Create a mint gives you an account here for the token mint. So create a token account is expecting create token account. Create token account. Use create test token account. That's what I said to do. And see. Yeah, I already have that here. So the error should be from here now. Address, the mint, the owner, and the amount. I think this is to let's see what happens on that dude. Why do I need to pass an address again? Create key token account. Create a pre-initialized token account for what address? So it's I pass an address. The address should be okay. Spell token account. Mint owner amount. Yeah. What's bugging me off now is maybe the checks are relaxed because a token account needs to be created from these 3 seeds. But now if I just put a random address, that should fail because it's not the right address. Yeah. But let's try. Let's put token address there. And let's put the token mint. What gets returned back? Token mint address and owner. Cannot find owner. This could owner will be the owner of this is the vault. It's called vault state. Vault state is the owner and amount. How much do I need to create this guy? Let me just mint the guy with. Wait. No. The owner should not be. Let's see. A minute, we'll get to it. So token account. Let's see what's going on that dude again. So creating a token account means creating a token account, creating an account, creating a key token account. This creates a pre-initialized token account. Then I need to know the address, then and the token. Trying to see if the intention here is to create a token or just mints the token. Because if that's what it's doing here, it's not doing any validation checks. maybe it's relaxed in the SVM. Because if you want to mint an account, you want to mint a token, you should be the owner of the token of a mint. If you want to mint a token to another person, you should be the owner of the mint. Yeah, I should be the authority of the mint. Then this address should be the PDA that was derived from the mint, the payer, and the program ID. So let's see. You don't want me to find out. Test. Let me remove this one. Let's remove this one first. But I will still want to put it there. The mint should be. Let me put the mint up here. Okay. I think I know what to do here. Let me just do the mint. Token mint. Yeah. Token mint is create a mint. Then payout byte token program ID. And we have token mint dot address. Should also be a borrow. Token mint dot address dot 2 bytes. Dot 2 bytes. That should fix it. So what our payer is a consider borrowing. Okay. Token program ID should be instead dot 2 bytes on it. Also, so if wallet address ID the mint, so we have wallet address ID and the mint. So this should be a valid token account. So that should be the valid vault token account. Yeah. But this one is the user token account, not the vault token account. User token account is this. Then the vault token account should be a copy of this. Vault token account, yeah. Vault token account here would be payer would be still be pay no payer now would be, so this is not payer actually, this is the owner. Yeah, so the owner will be the vault state. Vault state dot 2 bytes dot address. But address vault state is an address already, so just vault state dot 2 bytes. And that should actually fix it. Yeah, yeah. So now we have vault token account and we have user token account. User token account and vault token account. So let's use those. Yeah. So we have expected. Okay. User token account at position 0. Then SPL vault, that will be a vault token account at index 0. Let me guys. Yeah. Mm, then the mint. We also have the mint. Okay. Where did we get the mint from? We did a mint now at the top here. That's at mint address. Okay. We have a mint address. Mint address. Okay. Okay. I think that's all we need for the transfer. Oh, 1 minute, guys. Let me quickly attend to something. Uh, I am going to do. Okay. Opposite rolling. Yeah. So now the problem is to test, and now we should have the first breaking test. But yeah, let's see. Let's see. I think the first error here will be that the token account does not have balance. It doesn't have any balance. Okay. Now I can mint. Now I can mint as much as I like into the user account. So let me mint now. I need to mint into token address is not I don't token address here anymore. So for let's do minted um minted user ATA. Let's mint now. So we want to mint the user ATA. Token address is now the one that we have computed here from user token account. Token address. This address, okay, 1 minute. The address is mint, okay, address, mint, owner, and amount. The address I'm minting to the mint, the owner, and the amount. Okay. So the address I'm minting to is the user token account. That address, user token accounts. Okay, at 0 is the address. The mint is let's token mint the address. Token mint. Okay, the address. Then the owner here is payer. The owner of this is payer. No, let's see. Let's see. I think this one should fail. Let's make it. Let's make it vault states as the owner. Then mint user ITA. What do I get back? I get back an account. So let's use minted user ATA for the user token account. Let's use minted user ATA data address. So this is the only signer. And let's have our first error, guys. Let's go. Let's see what will be the first error. Yes. So we should have an error. But a lot of jumps that we did there. So let's see the jump. Got invalid instruction data for okay. I think I got the discriminator wrong for Libares. For deposit SPL is actually 3. Deposit SPL is 3. Then amount is U64. So what is the invalid instruction data? Oh, I did not build. Did I build? I think I built here. Okay, so what was the problem? Invalid instruction data. Discriminators 1, 2, 3. Deposit SPL. CTX account dot deposit SPL. Token program. Yes, I did not pass token program. Should pass token program. That's the problem. That's what I get for hard coding this thing. If I had used the client, generated client, would be good. So token program needs to be passed before system program. Token program needs to be sent before system program for initialize, and this one is for. So this I have token program here. One, two, three, four, five, six, 7 accounts. Then here in the instruction, we have 1, 2, 3, 4, 5, 6, 7 accounts. Okay, so let's see. I should have just used the instructional path. If this doesn't work, I'll use the instructional path first. So then inside our test SPL deposit, save, then let's test. So what's the next error? Yes, good, another error. Next error here is illegal owner for which account? Which account? Which account has an illegal owner? Provided owner is not allowed. It will probably be this. Did it even get to the? Did it get to the? No, I think it got there. Okay, so the owner here should be. I think it's this one that we are creating the account for. This mint account. Vault states. Mint address.